All right, welcome to geometry. Let's go ahead and get out our textbooks. Let's get out our supplements. We're on 216, which is on page 84 of your text or page 98 of your supplement. Page 84 of your text, page 98 of the supplement. We're going to start out right at the beginning of 216 real quickly. 216 is the last section before your next test. And so I'm going to make some accommodations and things for that, so don't worry too much about it, but I do want to make a couple of announcements. The first one is that your homework is due on Friday. So you should be pretty well close to done already with this section of homework. The only thing you should be waiting on is 216, which will finish by the end of class tomorrow. So that will be due on Friday. And then on Friday on Google Classroom will appear a quiz that is open book. Okay, so just chill. And you'll be taking that on Google Classroom. Okay, basically it's how we're going to do that, and then we'll take your quiz as an your test as an open book test on Monday and Tuesday. I think that's right. I don't have Monday and Tuesday's lesson plans in front of me. Okay, anyway, I'm going to go with that, and if there's a change, I'll announce it tomorrow. Okay, so just to be clear, you do have a couple things coming up, but they are open book, open supplement, one and the same. So just mentioning that there. Real quick, if you have not typed your name into chat, please do so. I have about half the class accounted for so far. So please make sure that you do put your name in chat. If you already have, please don't do it again. I don't need to be wading through it as we go. Let's see here. With that, though, we're going to get right into 216 with this, and we will get started here. Okay, cool. Just making sure I've gotten everyone in there. Again, if you've already put it, don't put it again. That would be helpful. All right, we're on section 216, and we're going to talk about something a little different today. We're going to talk about what if things are unequal. So we've talked a lot about equal lines and angles and things like that. We need to discuss what happens if they aren't equal. Can we prove anything then? It's not necessarily can we prove something else equal then, but we should be able to prove things along the same relationships. Okay, and so that's really what we're going to look at here. So as soon as I find the button, there we go. We're going to start out with Theorem 13. The proof is in your supplement on page 98. You will not see it on the screen. On the screen, all I'm going to have is the diagram and the theorem. If one side of a triangle is greater than the second side, the angle opposite the first side is greater than the angle opposite the second side. So we're given triangle ABC, in which BC is greater than AC. Okay, so BC is longer than AC, and we're going to prove that angle A is greater than angle B. Okay, that's the idea here. So first of all, we have our given, which is that triangle ABC in which BC is greater than AC. And so we're going to locate D on BC such that AC equals DC. Okay, and so basically what we've gone through and done is we've gone through and said, all right, this point here, if we measure this out with the compass, this distance equals this distance. Okay, and that's basically what we're doing here with point D. And so with that, let's see here. This is just by construction of equal line segments. With our compass, we can measure out CA onto CD, basically is the idea. And so we'll draw AD to point D on BC. So we're just going to go ahead and draw this line because 2 points determine a line, so we can. Now, angle BAC, so angle BAC is greater than angle Y. Okay, angle Y is just this internal angle. It's kind of hard to see on the screen, but it does stop at this dotted line. Okay, so we're not talking about the whole angle. So the whole angle is greater than the piece of the angle, basically, is what we're saying, because the whole is greater than any of its individual parts. Now, angle X is equal to angle Y because we've created an isosceles triangle. So we know angle X must equal angle Y. Which means that angle X must be less than angle BAC. Hold on. Right, which is substitution. Y has to be, angle BAC is greater than angle Y. Okay, then angle Y equals angle X, so angle BAC is greater than angle X by substitution. We're substituting in an equal for an equal. Now, angle X must be greater than angle B, because if you look at this, we formed two triangles inside this larger triangle. And so if we focus in on this triangle down here, okay, where we have, okay, if we look at this triangle, angle X is actually an exterior angle. And that would make angle B an opposite interior angle. And so because we have an opposite interior angle and an exterior angle X must be greater than the opposite interior angle of angle B. So that's step 7. And then by substitution, or sorry, not by substitution, we can't say that because we're not substituting equals for equals. But because angle X is greater than angle B, okay, then angle BAC must be greater than angle B, because angle BAC is greater than angle X is greater than angle B. So by the property of if A is greater than B and B is greater than C, then A is greater than C, the order axiom, that's the name of the thing. By the order axiom, angle BAC is greater than angle B. As you have already kind of figured out based on just the way I've had to word things, it can be a lot more roundabout to prove unequal things share a relationship than to prove equal things share a relationship. So just kind of keep that in mind. Keep your head on straight. Do one step at a time, and it will clear itself up. But that was Theorem 13. So now, if you can create this scenario where angle A is greater than, or sorry, where BC is greater than AC, then angle A will be greater than angle B. That is our proof. Okay, we've proven that, so now we can use that. That's the important bit. All right, still missing 2 people for attendance, so make sure that you please do that. But we're going to continue on here. Again, if you've already done it, don't do it again. I see it. Theorem 14. If an angle of one triangle is greater than a second angle, the side opposite the first angle is greater than the side opposite the second angle. Okay, these things tend to hurt my head when I'm reading them. So basically, this is the converse of Theorem 13, which basically in 13 we had unequal sides yield unequal angles. Now we're going to have unequal angles yield unequal sides, which makes sense. We could quickly do that through indirect method, but the direct method is shown here because it's typically the way we present it. So we have triangle ABC with angle A greater than angle B as our given. We are trying to prove that BC is greater than AC. So we're going to draw AD such that angle BAD is equal to angle ABD. Okay, basically we're trying to make this angle equal to this angle. That's the entire idea. Well, then that would make AD equal to BD. Then AD plus DC must be greater than AC. Basically, what's going on with our internet? Okay, I think we're back up. Just to let the record reflect, it's not my fault. I have good internet. I don't know what the problem is here. All right. Cool. Just making sure things are good. All right. Can everyone hear me again? I don't know why my computer suddenly decided I can't reach YouTube. All right. Someone let me know in chat. I'm going to hope so. Okay, cool. Yeah, I don't know what happened there. All right, moving on. The joys of streaming. Okay, so... All right, I'm going to write down 189 because that's the current number of dropped frames, and if I see that go up, I know there's a problem. Okay. So, real quick. Yep, train of thought derailed. All right. Basically, what we're doing here in step... Where were we? Step 4. Okay, so we've already said that AD is equal to BD. I'm actually purposely not marking that. And AD plus DC must be greater than AC because the sum of two sides of a triangle is greater than the third. And that's basically what we're saying there in step 4. So then by substitution, because AD and BD are equal, I can say BD plus DC is greater than AC, which you may have noticed means that this line is greater than this line. And that's all we were trying to prove in the first place. Okay. It takes 2 more steps because we have to state that BD plus DC is equal to BC by the whole is equal to sum of all its parts, and then substitute in. Okay. Let's see here. Okay. Looks like things are more stable now. Really don't know what happened there, but that's the joy of working on Wi-Fi because you can't run a wire where you are. Okay. Corollary 14. Corollary 14.1 says that the perpendicular is the shortest line that can be drawn from a given point to a line. This actually directly follows from the previous proof. Given that PC is perpendicular to AB and PD, any other line and any other line from P to AB, let's put it that way. Okay, we're going to prove that PD is greater than PC. So we are given these 2 lines, and we're going to basically prove there's only one perpendicular. I believe this has been proven previously. As an indirect proof. I think we did. I don't know, but either way, here's the direct proof. PC is perpendicular to AB, PD, any other line from P to AB. We're to say that angle PCD and angle PCB are right angles by definition of perpendicular. That makes them equal because all right angles are equal. PCB then is greater than PDC because an exterior angle of a triangle is greater than either opposite interior angle, which makes PCD greater than PDC, which means PD is greater than PC because if one angle of a triangle is greater than a second angle, the side opposite the first angle is greater than the side of the opposite, or than the side opposite of the second angle. Basically, Theorem 14 is our reason for step 6. All right, Corollary 14.2. Yep, there we go. All right, Corollary 14.2, if a line is the shortest line that can be drawn from a given point to a given line, then it is the perpendicular from the point to the given line. And we're using the same figure. Okay, whoops, here we go. Helps if I use the right arrow. So we're going to use the previous figure. It's on there on your diagram, but PC is the shortest distance from P to AB. We're to prove PC is perpendicular to AB. We do this using the indirect method. If we suppose that PC is not perpendicular to AB, then there exists a line PD that is perpendicular from AB, or to AB from P. Then PD is the shortest line drawn from P to AB because the perpendicular is the shortest line that can be drawn from a given point to a given line. That's Corollary 5-1. We've already proven that part. But this contradicts the given fact that PC is the shortest line from P to AB. Thus, the supposition is false and PC is in fact perpendicular. This is almost a non-proof as far as like what we actually have to say. But we had to do... we had to go through and do that. Oh, that's what it was. Okay, so we had a similar proof, but not that one. So we've got... we're covering all our bases, let's put it that way. All right, there are quite a few proofs in this section, which is why we're taking potentially 2 days on it, but just mentioning that there. So I do apologize as if this is a bit dry, but we're going to get right into Corollary 15-1. Theorem 15. Theorem 15. I already turned the one page. If 2 straight lines are drawn from a point in a perpendicular to a given line, and they cut off equal segments from the foot of the perpendicular, then they are equal. Okay? So we are given that RF is perpendicular to AB, P any point in RF, and PD and PE drawn from P to AB, making FD equal to FE. That's going to make PD equal to PE. This one's actually fairly easy to do. Again, the proof is in your text or in your supplement here. Okay, so if we have our given, and then PFD and PFE are right angles, which makes right triangles. PF is equal to itself. So therefore, we have congruent triangles by leg, and therefore by CPCTE, the hypotenuses, I still don't know what the plural of that word is. The two hypotenuses, I guess, are equal. Okay, so like I said, pretty straightforward, just quite a bit of writing. Corollary 15-1. If two straight lines drawn from a point in a perpendicular to a given line cut off unequal segments from the foot of the perpendicular, then the straight line that cuts off the greater segment is the greater straight line. Basically, we're proving that PD is greater than EP, given that they're making unequal lines. This is kind of a duh thing, so I'm just going to kind of run through the proof here. There are a lot of duh statements in here that you can then use to prove other non-duh statements. Okay, so we're kind of covering all the duh boring stuff right now. So that way when you guys go and do your homework, you guys can use them so you don't have to go through and reprove them, basically. All right, so we're going to draw GF equal to EF because we can. Okay, and then we'll draw GP by 2 points to determine a line. GP is equal to EP based on the previous, or based on Theorem 15. Then angle 1 equals angle 3 because angles opposite equal sides of a triangle are equal. Then angle 1 must be greater than angle 2 because it's an exterior angle to this triangle. Okay, so that's what we're looking at. Because it's an exterior angle, angle 1 must be greater than angle 2, which makes angle 3 greater than angle 2 because 3 equals 1. This makes sense, I promise. All right, anyway. And then that makes DP greater than EP. Theorem 16. Theorem 16 says that if two straight lines drawn from a point in a perpendicular and a given line are equal, then they cut off equal segments from the foot of the perpendicular. This is the converse of Theorem 13. Basically, we're handed that PD is equal to PE in this case, and we're to prove DF equals EF. We basically did the same thing except we use hypotenuse leg instead of leg, and I'm going to just straight up move on from there. Okay, but it's the same idea of proof as Theorem 15. I'm not going to go through it again. Corollary 16.1. Well, it's the converse of Corollary 15.1. So we prove this through indirect method. I'm actually going to go through this because this is kind of, or this can be a bit more of an interesting proof. So we're to suppose that DF equals EF for part A. You'll notice I have two parts here. So for part A, let's assume they're equal. Then DP is equal to EP by the fact that if two straight lines drawn from a foot and perpendicular to a given line cut off equal segments from the foot of the perpendicular, then they are equal. However, this contradicts the given fact that DP is greater than EP, therefore this supposition is false. Okay, remember we have the law of trichotomy in mathematics. Okay, so you have, it has to be greater than, equal to, or less than. So if we can disprove equal to or less than, it must be greater than. That's what we're doing here. So we disproved equal pretty quick. Let's disprove less than. Suppose DF is less than EF, then DP is less than EP, by the fact that if two straight lines are drawn from a point in a perpendicular to a given line cut off unequal segments from the foot of the perpendicular, then the straight line that cuts off the greater segment is a greater straight line. However, this contradicts the given, therefore the supposition is also false, and DF is greater than EF by the law of excluded middle. That's what we have to prove. Okay, so just mentioning that there. That's the indirect method. Again, I know I'm kind of burning through it, but I'm trying to burn through some of these here so we can get to one that you guys actually need to do. All right, so as far as where you're not just using something that's proven. All right, so Theorem 17. If two triangles have two sides of one equal respectively to two sides of another, and the included angles are unequal, then the triangle which has the greater included angle has the greater third side. Okay. We are given triangle ABC and triangle DEF with AC equal to DF and BC equal to EF and angle C is greater than angle DFE. Okay, we're to prove AB is greater than DE. Okay, basically is the idea here. Okay. Now, this diagram looks like I did something real funky to it. Basically, what we have first is the solid lines. Okay, so we have triangle ABC and triangle DEF. Okay, the parentheses are what we're going to do later. Okay, but for right now, DEF. It's just the way we have to draw this diagram in order to kind of get it across as to what we're doing. So let's get right into it. First of all, we have our given. Second of all, we're going to draw angle C at F. So basically what we're doing is we're copying this angle over to this angle so that CA coincides with FD. So basically we're trying to move this triangle over. And what's going to happen is A and C will line up. We're going to get angle C lined up here, and that's going to create, this dotted line here, okay, which is going to give me this line here. And so I'm going to have line EG created here, but that's not done yet. Okay, so I'm basically just copying this triangle over to here, and that creates essentially this. Okay, so this triangle is that triangle. Okay, just mentioning that's what we're doing there in step 2. Basically what we did is we copied angle C on this side, and then we copied angle A. And so what we do have to say is that, let me use something other than yellow. This side and this side have to meet at point G because two lines have to intersect, and so we're saying that's where they intersect. Essentially, yes, that is point B. We copied the triangle, but we can't exactly say that. So, all right, gonna delete everything. All right, then I'm going to draw EG because I can. Okay, so I'm not trying to make a three-dimensional thing here. Your brain almost tricks you into thinking that this is what I'm doing, is like I'm creating some sort of weird edge. Okay, I'm really not. It's just the perspective we have to draw it. So we're drawing EG. Then triangle ABC ABC is congruent then to triangle DGF. Again, we just copied this triangle is this triangle. That's what we're saying for sure in step 5 by angle side angle, because we went through and copied it directly. Let's see here. Now AB is equal to DG and CB is equal to FG by CPCTE. Because we have all that, then FG is equal to FE by substitution. Because we knew BC equaled FE, then FG also equals FE, and so hence the single tick mark on both. Then angle FEG. So this, let me clear it again and grab a different marker. This angle then is equal to this angle because we have a triangle created over here with equal sides. They're opposite those, and so these two angles are equal. Now DEG, okay, so this wide angle, wait, what? DEG is greater than FEG, right, that makes sense. Okay, I was looking at it weird. And FGE is greater than DGE, okay, because the whole is greater than any of its parts. So then DGE is greater than FGE by substitution, and DEG is greater than DGE based on our order axiom. Then DG is greater than DE. Okay, which is important because then by substitution, AB, which was our original goal, AB is greater than EG. Or sorry, DE. DE. Okay. So that's kind of a long story there. This one's kind of a more rough one to follow. Okay. But basically now, as far as a proof goes, but the concept is pretty simple. If you have two triangles with two sides respectively equal to two sides of the other, but the included angles are unequal, the triangle with the greater included angle has a greater third side. So in our original diagram, if you ignore all the dotted lines, okay, this angle here was greater than this angle here. And in so doing, this side, this one is bigger than this side. Okay, that's what we were proving. Again, I know that was probably a little difficult to follow, but there it is. It's done. Let's move on. All right, Theorem 18. If two triangles have two sides of one equal respectively to two sides of the other, and the third sides are unequal, then the angle which has the greater third side has the greater angle opposite the third side. We prove this by contradiction because basically in order for anything else to be true, it would contradict Theorem 17. Okay, we could go through and read it if you want, but there it is. All right, that's where I'm going to leave that. Let's go on to 216, number 8. Exercise 216, number 8. All right, you guys have some blanks to fill in, so hopefully you're still awake and paying attention. Again, do apologize that was kind of dry, but it's just the nature of this section. We are given that AC is greater than BC, and D is the midpoint of AB, and we're trying to prove that CDA is greater than CDB. Okay, so we need to prove, basically, our goal here is to prove that this angle is bigger than this angle. Okay, that's the idea. So first of all, we have our given. I'm not going to rewrite the given. You have it. So we're going to start out with step 2. Step 2 says that AD is equal to BD. Okay, well, we're told that D is the midpoint of AB, so AD is equal to BD by the definition of midpoint. Number 3, we are given in our supplement that DC is equal to DC. Anytime we have something equal to itself, we just write identity as the reason, because of course something is going to equal itself. Duh. Okay, unfortunately we can't write duh as a geometry reason, so we use identity. We just think duh every time we use it. And then finally we're given that angle ADC is greater, oh goodness, C is greater than angle BDC. Okay, and that reason is Theorem 18. There is a large space in your thing because I actually wrote out Theorem 18. It's Theorem 18. I'm not rewriting all that. All right, so that means you guys don't have to either on that one. Okay, so that's from the section. So hopefully that helps. Hopefully that makes things make sense of how you approach unequal problems. That gives you some more tools to work with, and that's really the important bit, because that means we just finished section 2.16 as far as what I have for lecture. And so your homework begins on the next page. Again, you should have been working on it throughout. Your homework is due once a test, basically, is how I work it in this class. At least for now. That will probably change about halfway through the year. But as we continue on, if you keep looking, the exercises, you should have been done already at this point through page 113 with your homework. If not, anything you have before that is on you, because that's something you should already have done. And then starting today, you were assigned 12 through the end, which there are a couple proofs and a couple questions. So really not too bad. Because that's the end. That's all I'm going to cover until your test. There will not be a separate geometry stream tomorrow. Tomorrow is just a work day. Get your homework done. Okay? Because that, so I will not be streaming this class tomorrow. Okay? Let me say that again. I will not be streaming this class tomorrow. Okay? Tomorrow is a work day. So you guys have extra time to get your homework done if it's not done. So if you haven't started, for example, because I know the tendency to procrastinate, you have a whole day to work on it. So you have a work day tomorrow for your homework, 2.5 to 2.16 due. And let me go through and double check. I'm on my, yeah, okay. I'm just on my camera so you guys can't see what I'm doing. Let's see here. It's the problem with display sharing. I have to make sure you guys can't see some things. All right, geometry, classwork. Yes, okay, so your homework is due on Friday. Quiz 14 over 214 to 216 is a Google Doc that you will actually edit online on Friday. That will appear on Friday. Again, no stream that day either because all you're doing is taking a quiz online. That's it. And then Monday, Tuesday will be test 3, open book, open supplement. If you'll need study hall time, you can use that as well in addition to the class times or that optional 2:15 to 3 period. You guys can use that time as well. So you guys have plenty of time, but basically I'm giving you guys time to work so that basically you guys have time to finish your homework and actually look things over. One quick hiccup with that test, one quick note, I guess, maybe not hiccup. That test is a cumulative test, so it's from 1.1 through 216. So yes, it's open book, it's open supplement. I would go through and review a little bit too, because you're going to want to know quite a bit of it off the top of your head. So that's what we're going into starting out. But just want to mention, you guys already have your homework placed to turn in on Google Classroom. Your quiz will not appear until Friday morning. It will appear Friday morning, so you're welcome to use the class time to work on it. Again, it's open book, open supplement. It's just on Google Classroom. If you're a distance learner, you're probably used to link it. That's where your test will be next week. But the quiz I just recreated on Google Classroom because it was open book anyway. All right. So hopefully that makes sense. I will see you all on Monday then. Make sure your homework is turned in on Google Classroom. If you need your Google Classroom password reset or something, please email me or text me or send me a message on my schoolworks. I'm checking everything. So make sure that you guys have that done because that's it. I will not see you guys until Monday when we go through and do the test. So that will be the next time we have a class or have stream will be that. What's going to happen now is I'm going to end this stream and you guys will, it will be on the same channel still, and I'll set it up for Mr. Brown, for his science class. I'm not sure who's teaching it today, but for his science class on that stream. All right, so I'll see you guys later.